registers of 8086 microprocessor. Let's have the 14 16-bit register. Thus, all this register is subdivided into different groups. This namely general purpose register, that is a data register, statement register, pointer register, index register, instruction register, and flat register. So I'm going to the general purpose register or data register. There are the 8 general purpose register, that is AH and AL, that is AH and AL. AH means higher order address and L for lower order address, that is the AH register pair. BX register pair, that is the BH and BL. CH and CL is going to the CX register pair. DH and DL under the DH register pair. This is the 8 general purpose register. Registers can be used individually to store 8-bit data and can be used in pairs to store the 16-bit data. The valid register pairs are AH and AL, BH and BL, that is a BH, CH and CL, that is CX, DH and DL, that is a DX. Referred to as the AX, BH, CX, and DX. That's the general purpose register or register pair. First, I go into the AX register pairs, that is in the AX register pair, AH and AL are the general purpose register. It also known as the accumulator register pair. It is used to store operands for the arithmetic operations. Next is BX register pair. That is that contains the BH and BL register. It's used as a base register and it stores the starting base address of the memory area location within the data segment. And just later on, we discuss about the data segment. Next, I'm going to the CX register. It's referred to as a counter. It's used to in loop instruction to store the loop counter. Next, the DX register, that is the data register, is used to hold IO port address for the IO instruction. IO port address for the IO instruction. Next, that's the general purpose register. That's 4 general purpose register pair, that is AX, BH, CH, DX, and 8 general purpose register AH, L, BH, BL, CH, CL, DH, DL. Next, I'm going to the most instrument, that is the segment register. What is the segment register? First, discuss about the segment register and discuss the U register, and the last one is that BIU register. That's a 2 group. The instruction unit register, in execution, that is a EU means execution unit register, and BIU, that is fast interface unit register. U means execution unit register, that is contains the general purpose register, index register, there is the pointer register, flat register, and in the BIU register, the fast interface register, is contained the segment register. Now I discuss the segment, what are the segment register in 8286. Fast interface units has the 4 segment register, that's CS, DS, SS, ES. CS stands for the code segment register, DS data segment register, SS stack segment register, and ES extra segment register. This first I go into the code segment register. Code segment register is used for the addressing a memory location in the code segment of the memory where the executable program is stored. Code segment means যেখানে একটা মেমোরি লোকেশনে যে অ্যাড্রেস সেটাকে আমরা কি করছি কোড সেগমেন্টকে কিন্তু ইউজ করছি সেই মেমোরি লোকেশনটাকে ধরে রাখবার জন্য যেখানে প্রোগ্রামটা স্টোর হবে যেটাকে আমরা ইনিশিয়াল মেমোরি লোকেশন বলি সেরকম একটা রেজিস্টার কোড সেগমেন্ট রেজিস্টার যেখানে আমরা কোডগুলোকে দেব অ্যাড্রেসিং অফ দ্য মেমোরি লোকেশন কোড সেগমেন্ট অফ দ্য মেমোরি next one is the data segment register. It consists of data used by the program or access in the data segment by an offset address or the content of other register that holds the offset address. That means that in the data segment, that's the points to the data segment of the memory that the data is stored. Data আমরা store করব, that's is called the data segment. And the code segment যেখানে memory location নিয়ে যে addressing থাকে সেখানে আমরা store করব, store segment যেটাতে কোডগুলোকে আমরা store করছি. And the next one is the extra segment that is used for the another data segment of the memory যেখানে আমরা এক্সট্রা কোনো কাজ করবার জন্য যেগুলোকে ইউজ করব that is the extra segment. And the last one is the stack segment that is the temporarily যদি কোনো ডেটাটা স্টোর করতে হয় আমরা কি ইউজ করব stack segment register. It's used for the addressing stack segment of the memory in which the stack data is stored. Stack for temporarily storing data. Stack is used for temporarily storing data. Clear? Next. কেন হঠাৎ করে আমরা সেগমেন্ট মেমোরি করলাম? What is the reason behind it? 8086 has a 20-bit address bus, so it can address maximum of 1 MB of memory, and each memory location is addressed by a 20-bit address. সেই আমরা সেগমেন্টে ডিভাইড করছি, পার্টে ডিভাইড করছি. And to hold a 20-bit address, there must be a 20-bit address register available within the processor. But 8086 only has 16-bit register. So 20-bit address cannot be stored inside the 16-bit register. Avoid this problem, segmented memory is used in 8086. তার মানে কি 20-bit address? মানে 20-bit address register দরকার. আমার রয়েছে কত 16-bit register. So 20-bit address register cannot be আমি স্টোর করতে পারবো না 16-bit এ. সেই জন্য কি সেগমেন্টেড মেমোরি করব যাতে পার্টে আমরা স্টোর করতে পারি. Total at 1 MB memory can be divided into some equal size segment, each of having capacity of 64 kilobyte. Number of segment is 16. 1 MB divided by 64 kilobyte, that means 16. Work with only 464 KB segments at a time within this 1 MB range. Each location in a particular segment can be expressed by the two addresses. That is a segment address, and another one is the displacement address. তাহলে সেগমেন্ট কেন আমরা করি, সেগমেন্ট মেমোরি কেন আমরা করি, দ্যাট ইজ দ্য রিজন হচ্ছে 20-bit অ্যাড্রেসটাকে আমাকে স্টোর করতে হবে ইন 16-bit রেজিস্টার. দ্যাটস ওয়াই উই নিড দ্য সেগমেন্টেড মেমোরি বা সেগমেন্টেড memory in 8086. Next, I'm going to the advantage of memory segmentation. Key advantage which the memory capacity to be 1 megabytes, actual address to be handled at 16-bit size. Follow placing of code data stack pointers portions of the same program in different parts of the memory for data and code protection. Data একদিকে স্টোর করব, কোডটাকে আরেকদিকে স্টোর করব, data and কোডটাকে protection হচ্ছে. Permits a program or its data to be put into the different area of the memory each time the program is executed. This is clear? Next, other register. There is a stack pointer register. It's a 16-bit register which holds the address from the start of the segment to the memory location. কোন অ্যাড্রেসটা হোল্ড করছে? Start of the segment of the memory location. Clear? যেখানে start point সেটাতে কি করছে? Or the stack point is used to locate the stack top address. Also be this. Next is the base pointer. 16-bit register used to hold the offset address for stack segment. Used for base index, register index addressing. Next is source index and destination index register. This also the 16-bit register. ECE used for index, base index, register indirect addressing as well as source data addressing. And there is the destination and index. You can clear it in the after the few lectures. In the instruction set, you can clear it. The example, using the example. After that, this is the flat register in 8086 microprocessor. What are the flat register? 9 flat register. Always I say that is the in 8086 9 flat register. What are they? The first one, there is the OF, overflow flag. DF is the direction flag. IF is the interrupt flag. TF is the trap flag. SF is the sign flag. 0 is the JF is the 0 flag. AC is the auxiliary flag. PF is the parity flag, and CF is the carry flag. This is the first time going to the carry flag. This flag indicates an overflow condition for arithmetic operation. We also know that this carry flag in the 8085 microprocessor. This is the auxiliary type. When an operation is performed in the ALU, its result in a carry or borrow from lower level D0 to D3 to the upper level, that is the D4 to D7. Then this flag is set. That is the carry driven in the D3 bit or D4 to AFE. That's the auxiliary flag. Operation is performed in the ALU. Its result in a carry from the lower level, that is D0 to D3 to the upper level, that is the D4 to D7. This flag is set. When the auxiliary flag create hobe, when the auxiliary flag set condition. Parity flag. Parity flag also indicate the parity of the result. Lower order 8 bits of the result contains even number of 1. So even number of 1 third on parity flag set hobe. Odd number of 1 third parity flag is a condition. Next is the 0 flag. Flag is set when the result of arithmetic or logical operation is 0. So result is 0 পাবো তখন আমরা কি বলবো? This 0 flag is the set condition. Next is the sign flag. The flag holds the sign of the result. That is when the result of the operation is negative, then the sign flag is said to be 1, otherwise 0. Next, we divide this flag register into the conditional flag and control flag. What is the conditional flag? The carry flag, auxiliary flag, parity flag, 0 flag, sign flag, and overflow flag are the conditional flag. And next time discuss the control flag. What are they? Control the operation of execution. That's the first one is trap flag. It's used for single step control and allows the user to execute one instruction at a time. কি করছে যে ইউজারকে অ্যালো করবে যে একটা ইনস্ট্রাকশনই at a time কিন্তু এক্সিকিউট হবে। Interrupt flag, if it is set, then the program can be done in a single step mode. Interrupt flag, it is an interrupt enable or disable flag that is used to allow the interruption of a program. It's used set to 1 for interrupt enable condition and set 0 interrupt disable condition. Directional flag used in string operation. As the name suggested, when it is set, string bytes are accessed from the higher memory address to the lower memory address, and when it is low, then the string bytes are accessed from the lower to higher. তাহলে যখন হায়ার মেমোরি অ্যাড্রেসে লোয়ার মেমোরি অ্যাড্রেসে জিনিসটা কাজ করবে তখন সেটা 1 হবে ডিরেকশনাল ফ্ল্যাগ, এবং লোয়ার থেকে হায়ার হবে তখন সেটা 0 হবে। These are the flag register of 8086 microprocessor.